In this video, we will see the definition of amicable numbers and perfect numbers and problems based on them. Two numbers, n and m, are said to be amicable numbers or friendly numbers. If you take them as n and m, then this is the condition. Sum of divisors of n minus n should be m, and sum of divisors of m minus m is n. So sum of divisors of n minus n should be m, and for sum of divisors of m minus m, it should be n. If we have these two conditions to be true, then we call n and m to be amicable numbers or friendly numbers. Now, if we are given 220 and 284, we would like to show that these two are amicable numbers. So already definition we know, that is given here again. Sum of divisors of n minus n should be m, and sum of divisors of m minus m should be n. Now we consider 220, which we can write as 2 square into 5 into 11. We know the method to write this as product of prime powers. Using this, we can write 220 in this way. And having written this in the form P power A, Q power B, R power C in that format, using this formula, sum of divisors given by P power A plus 1 minus 1 by P minus 1 into Q power B plus 1 minus 1 by Q minus 1, and so on. Here P, Q, R, they stand for 2, 5, 11, and A, B, C are nothing but 2, 1, 1. So this is what we have, and this on simplification gives you this 8 minus 1, 25 minus 1, 121 minus 1, and the denominator 1, 4, 11 minus 1, that's 10. So this again on simplification gives us this. Further simplification gives sum of divisors of 220 to be 504. So sum of divisors of 220, namely 504 minus 220, gives us 284. Let us name this as equation 1. And similarly, we shall consider 284, which we can write as 2 square into 71. Again, make use of the formula to compute your sum of divisors of 284. And here A is 2, B is 1, and the prime numbers are 2 and 71. So 2 plus 1 minus 1 by 2 minus 1, and here 71 power 1 plus 1, because B is 1, minus 1 by 71 minus 1. So you get 2 cube, that is 8 minus 1, and here 71 square that we have, and simplification gives us that 504 as the sum of divisors of 284. Now again, by the definition, sum of divisors of 284 minus 284, namely 504 minus 284, gives us 220. If we name this as 2, then from 1 and 2, we see that the condition is satisfied, and therefore we have these two numbers to be amicable numbers. So next we have the definition of perfect numbers. Number n is said to be a perfect number if sum of divisors of n minus n is n itself. Sum of divisors of n minus n is n itself. So in this we are asked to show that these three numbers are all perfect numbers. First we consider 6, which we can write as 2 into 3, and sum of the divisors by the formula we have this. Here 2 and 3 are the prime numbers. In the index we have A to be 1, B to be 1, so we have this. On simplification gives us 3 into 4, that is 12. So sum of divisors of 6, 12 minus that number itself. So 12 minus 6 is 6. So 6 is a perfect number. And similarly, when we consider 28, it is 4 into 7. 4 is written as 2 square. So again 2 and 7 are the prime numbers. A is 2, B is 1. So we have from the formula we have this. On simplification gives us that 7 into 48 by 6, that is 7 into 8, and 56. So sum of divisors of 28 minus 28, namely 56 minus 28 is 28. And therefore 28 is also a perfect number. Then the next one, if n is 496, that is rewritten as product of prime powers. That must be written first, only then sum of divisors this formula can be used. So that using that formula, this is what we get, that is 992 minus 496 gives 496, and therefore again by the definition we have n, namely 496, to be a perfect number. Now we have a problem which can be treated as a result also. We are given 2 power n minus 1 to be a prime number. Such a prime number is given to you. You are asked to show that that number multiplied by 2 power n minus 1 is a perfect number. So this being a prime number, we shall take that as, say, some p. So that this n, which is taken as this given number, will now become 2 power n minus 1. This number is taken as p. So you have this into p. Now you have n to be product of prime powers. One prime is 2, the other one is p. In the index of 2 you have, that is in the place of a, you have n minus 1. So 2 raised to a plus 1, that is n minus 1 plus 1 by 2 minus 1. And here b is 1, so p power 1 plus 1 minus 1 by p minus 1. So this on simplification gives you 2 power n minus 1, and this is p square minus 1 by p minus 1, which we can write as p minus 1 into p plus 1. Cancelling that p minus 1, we have p plus 1 from here, and this 2 power n minus 1 already is taken as p. So sum divisors of n is given in terms of p as p into p plus 1. Now again, since p is taken as this, 2 power n becomes p plus 1. So 2 power n minus 1 will become p plus 1 by 2. So that when you just cross multiply, you will get 2 power n to be this. So you have 2 power n minus 1 to be this. Now we shall consider n, which is this. That's what is written already. This number is p. So you have this. Now 2 power n minus 1 is p plus 1 by 2. So your n now becomes as this. So we are converting everything in terms of p. So that the subtraction can be performed. So sum of the divisors already p into p plus 1, and here minus n is this. So that in turn gives p into p plus 1 by 2. But p into p plus 1 by 2 is nothing but our n itself. P into p plus 1. This p plus 1, we have p plus 1 by 2 is 2 power n minus 1. So that 2 power n minus 1 is here. And this p is nothing but this. So we are getting p into p plus 1 by 2 as n itself. Sum of divisors of n minus n gives back n, and therefore our n is a perfect number. Thank you.